Now there are mainly two methods to calculate resultant. The first one is by using method of resolution. Second, you can calculate by using law of parallelogram of force. Now let us start first with method of resolution. Now already you know how to resolve the forces into two perpendicular components. So we are going to find resultant, the resultant of all the force system, whatever we have discussed just now, concurrent force, non-concurrent forces, parallel forces, and then collinear forces. So by using first method, that is method of resolution, whereas law of parallelogram of force, that is applicable for only two forces, and that too they are concurrent, that we will be discussing later on. So let us first start with the method of resolution, and that too for first subtype, that is concurrent force system. So resultant of concurrent forces. You know what exactly is concurrent force? So in concurrent forces, all the forces will pass through a single point. Say that point is O. F1, F2, F3, say F4. Like that you can have number of forces passing through single point. Now in case of method of resolution, you are going to calculate resultant of concurrent forces by resolving the forces. You know how to resolve the forces. So very first thing is, you have to resolve the force, you have to show the resolution. Inclination is given. So theta 1 is inclination of F1 with horizontal, theta 2 for F2, theta 3 for F3, whereas F4 is horizontal. You know, when force is horizontal, then theta becomes 0. So now let us show all the resolution of forces. Now F1, you know, it is acting this way. You know how to resolve the forces. Now these are the two components along x and y direction. So when you resolve F1, you have two components. This is force along x direction for the first force, Fx1, and whereas y component is given by Fy1. Now for the second one, F2, it is going this way, and these two are the components of forces along x and y direction. So x is right, y is down. Fx2, and this is Fy2. For F3, same way, when you resolve, you get Fx3 and Fy3. Whereas here for the F4, you know, the force is acting purely along x direction, it will have only x component, whereas its y component is 0. But anyway, you can generalize x component as Fx4 and y component as Fy4. Now what are the methods? How to get resultant of concurrent forces? So there are mainly 4 steps. Step 1. Step 1. You have to resolve first all the forces along x direction, and then you will have to consider the summation of all those forces. So the very first step is algebraic sum of all the forces along x direction. So that is Fx1, Fx2, Fx3 plus and so on. It depends on number of forces. Here we have taken up to 4th force, you can go up to 4. If there are more, then so on and so on. So here you know, along x direction force can be towards right or left. So you can generalize this, it can be plus or minus. You know when to take plus and minus, plus for right and minus is for, plus is for right whereas minus is for left. Similarly here plus or minus, plus or minus, plus or minus and so on. So this is the step 1. Whereas the second step is resolution of all the forces. Step 2, you are going to resolve all the forces along y direction, that is already shown here, and take sum of all those forces, that is summation of Fy. So it is y component of first force Fy1 with plus or minus, for the second force it is Fy2, third Fy3, and so on. That depends on number of forces. Now you know sigma Fx and then sigma Fy. After substituting the values of all these x and y component, you get sigma Fx as either plus or minus. Same way for sigma Fy, you may get either plus or minus total result. Let us assume you are getting positive answer. For instance, for example, sigma Fx you are getting positive and sigma Fy is also positive. So that means what? Sigma Fx and sigma Fy positive indicates that comes under step 3. Step 3. Now to find resultant. So we are assuming that sigma Fx you are getting positive. Positive indicates the direction is towards right. Sigma Fx, because I am assuming it is positive. Same way sigma Fy is also positive. That means its direction is upward. If you get minus, only thing is you have to change the direction. Now resultant is going to be somewhere in between. So now that resultant, to get resultant, let us construct a rectangle as shown. If you use a vector approach, the resultant is going to be somewhere in between. So this is R. Now what you can see here is sigma Fx and sigma Fy, they are the resolved component of resultant. If you consider a right angle triangle OAB and say R is making an angle theta with sigma Fx or horizontal, that is the general practice we follow. So here you can easily calculate resultant by using Pythagoras theorem. We require resultant. So from right angle triangle OAB, what you can write here, apply Pythagoras theorem. From Pythagoras theorem, OA square is equal to OB square plus AB square. Now along AB, you know, vectorially you can shift sigma Fy over here. Substitute OA, OB and AB. Along OA you have resultant R, it is R whole square. OB is sigma Fx, it is whole square, plus AB sigma Fy, the whole square. Now from this you get the value of resultant. R is given by root of sigma Fx or summation Fx whole square plus summation Fy whole square. So now this is very important equation to calculate resultant. Now final step, after getting step 3, the last step is finding its direction, because you know resultant is also a force, it is a vector quantity, it is having both magnitude as well as direction. So magnitude of resultant is given by equation 1. So this will give you magnitude of resultant. Now in step 4, we will calculate direction. To find direction of resultant, that is theta. Now how do you get theta? When sigma Fx and sigma Fy are known to you, then you can use trigonometric relation to get theta. Tan theta is given by what? Opposite side by adjacent side. So tan theta is sigma Fy by sigma Fx. Now from right angle triangle OAB, from the same right angle triangle OAB, let us use tan theta there. So tan theta is given by opposite side AB along AB you have sigma Fy divided by OB you have summation of Fx, or theta is given by tan inverse of summation of Fy divided by summation of Fx. Kindly note, always this theta is mod value. Even if you get minus, you keep that as the positive answer. So now theta is what? Inclination of resultant, always that is with horizontal here also. So this is with theta is inclination with summation of Fx line. So I think now it is clear. Majorly altogether you have 4 steps to calculate resultant, right? Even same step we use for resultant of non-concurrent forces, parallel forces and collinear force. So what are the 4 steps here? First one, you will have to resolve the forces along x direction and add those forces, you get summation of Fx. Second step is resolve all the force along y direction and add those forces, you get summation Fy. After that, the next step is finding magnitude of resultant. So for that we are assuming sigma Fx, sigma Fy along x and y direction positive. Now resultant will be somewhere in between. So from this diagram what you get is r square is given by sigma Fx whole square plus sigma Fy whole square. So finally you know how to get magnitude of resultant, that is this equation under root sigma Fx whole square plus sigma Fy whole square. This will give magnitude, and the last step is to find the direction, that is by using this equation, theta equal to tan inverse of summation of Fy by summation of Fx, that is with the summation Fx. This theta is always with summation Fx.